Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session, we'll be showing you how to use HSS on undercut surfaces. If we take a look at this part, especially at this hole here for a moment, and I'll cut it away so you can actually see what it looks like inside. You can see at the bottom of the hole, we have an undercut surface that we have to machine, and the only way that can be done is by using HSS. There is no other tool that we can use for doing this type of a surface. Let's take a look at the operation that we've done over here. We'll go into the operation itself, and you'll see that we've used HSS perpendicular to the curve. In other words, moving up and down on the curve itself. This is necessary because we'll be using a very small T-cutter to go into that hole itself, because the diameter of the hole that we have over there is only 8 millimeters. The drive surface will be this surface that's underneath over here, and the curve itself will be this edge that's on the top of that surface. The tool that we'll be using will be a 7 millimeter slot mill with a full radius on the cutting edge itself. If we take a look at the tool itself, you'll see that the arbor diameter is only 2 millimeters in diameter, and the tool itself, the diameter is 7 millimeters. This is necessary in order to get to the entire surface and also be able to enter the hole that we have over there. The toolpath parameters will be using a maximum step over of 0.1 millimeters. And if we go into our gouge check, you'll note that we'll be using both our first and second gouge. Let's go into our second gouge for a moment, and you'll see that we'll be using the following surfaces. We'll be checking to make sure that the arbor or the tool does not hit any of this surface over here. Therefore, we'll be using all of these options over here, that neither the tool tip, tool shaft, or the arbor won't hit that surface. And we'll also be staying 0.05 millimeters away from that surface. We'll be leaving out our gouging points without trimming the tool path, allowing for our tool to go exactly through the hole without hitting the edge itself. If we take a look at our simulation itself, you'll see that the tool path goes in and works its way around that surface, working up and down on the surface itself, getting to every single one of those surfaces. Now, if we take a look at our simulation using the Solid Verify, and let me zoom into this area, you'll see that the tool goes in and works exactly inside that hole, underneath, without having the arbor hit that hole. That's because of our gouge check. You'll see our tool works up and down, working around that entire hole, getting to every single one of those, to every single part on that surface itself. And then when it finishes, it'll go straight out of that hole without any difficulties and without worrying about hitting that hole itself with the tool. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.